Hello guys, this is Shoaib Yaqub. In this video, we are going to cover that how to calculate interest rate conversion with the help of calculator. So we will learn that how to calculate the effective annual rate, the nominal rate, which is compounded annually, monthly, semi-annually, and quarterly. So let's learn the interest rate conversion. For example, today is year 0 and at year 1 we are going to receive $100 and the rate of return is 10%. This is the annual rate. Whenever rate is given, obviously it will be the annual rate, and this annual rate will always be the nominal rate. And this is compounded annual. Compounded annual. It can be compounded monthly, quarterly, semi-annually, annually, but in this example, it is compounded annually. So the nominal rate is given. Remember, whenever rate is given, it is always assumed to be the nominal rate. So now learn that how to calculate the effective annual rate with the help of the calculator. So we will learn that how to calculate the effective rate if there is a 6-month compounding, there is a quarter compounding, there is a monthly compounding, and there is an annual compound. So first of all, let's calculate if there is an annual compounding, what will be the effective annual rate? Effective annual rate. I'm assuming that this is the nominal rate. So press second and this 2. This is I conversion. So press the nominal 10% rate here. 10, press enter, arrow down. This is the effective annual rate. This is the compounding per year. How many times you will compound in a year. So this is the annual rate. So compounding will be 1 in a year. Enter. So now calculate the effective annual rate. This will be 10%. So the nominal and effective annual rate will always be same if there is a compounding once in a year. So annual rate is 10%. Compounding is once in a year. So effective annual rate will be the 10%. So now let's learn if we want to earn the same effective annual rate, what will be the nominal rate of 6 months, what will be the nominal rate of 3 months, and what will be the nominal rate of 1 month. So this is a very important concept. Try to digest this. First of all, 10% nominal rate is given. So I'm assuming there is a compounding annually. So what will be the effective annual rate? Effective annual rate will be 10%. So now if we want to earn the same effective annual rate, what will be the nominal rate of 6-month compounding if we compound cash flow in a 6-month time? So how to do it? Arrow down. Now we want to compound it twice in a year, so it will be 2. Factor and keep the effective annual rate same. Compute the nominal rate. So it will be 9.76. 9.76%. So this will be the nominal rate. This will be the annual rate, obviously. And why it is lower than the 10%? Because in a 6-month time, you will compound it twice in a year to make it exactly equal to the effective rate of 10%. So here, nominal rate is 10%. In order to achieve the effective annual rate of 10%, here, in order to achieve the same annual rate, effective annual rate of 10%, nominal rate is 9.76. Why it is lower? Because in order to achieve the 10% after 1 year, you have the liberty to compound this twice in a year. So that's why this rate will be lower. Even in quarterly, this rate will be lower compared to the 9.76%. So in order to earn the same effective annual rate, let's calculate what will be the nominal rate in a 3 month time. So there will be 4 quarters in a year. So this will be 4, enter, arrow down, keep the effective annual rate same, calculate the nominal rate. This will be 9.645%. 9.645%. So why it is lower? Because there will be a 4 times compounding in a year. So when there is a 4 times compounding in a year, this rate will be used to achieve the effective annual rate of 10%. So what about the monthly? In monthly, compounding will be 12 times in a year. By keeping the effective annual rate same, calculate the nominal rate, that will be 9.57%. So, and what about the continuous compounding rate? Continuous compounding. Continuous compounding means compounding will be many times in a year. It keeps on compounding continuously. Although there's a log normal function for it, but we can use I conversion using approximate. That is, compounding, continuous compounding will be, you will put the maximum value here, the highest possible value in a compounding in a year. Enter it, keep the effective annual rate same, calculate the nominal rate, that is 9.53%. 9.53%. So there is another way to calculate the continuous compounding rate, that is the log normal. So how to calculate the log normal? As we know that if there is a return of 10%, that means after 1 year, you will achieve 1.1. If there's a return of 10%, so that means if you have $100 cash flow, after year 1, you will be achieving $110. So if you have $1 now, after 1 year, it will be 1.1. So in order to achieve 1.1, what will be the nominal rate? So put 1.1 here, exit this function, second and quit, 1.1 by calculate the log normal. This is 9.53. So it is almost equivalent to the 9.53. So by using the log normal function, you can calculate the continuous compounding rate. So let me conclude all this. So in order to earn effective annual rate of 10%, if you compound annually, your nominal rate will be 10%. In order to achieve the effective annual rate of 10%, if you compound 6 monthly, the nominal rate will be 9.76. In 3 months, nominal rate will be 9.645. And in order to achieve the effective annual rate of 10%, if you compound monthly, your nominal rate will be 9.57. Why it is lower? Because it will compound 12 times in a year to get the 10% answer. So now discuss, if we discount this $100 back to zero, so what will be the present value by using all these discount rates? And if all have the same effective annual rate, present value should be same. So let's discount this 100 using the annual rate. So let's calculate it. Let's take exit from here, second and quit. So let's clear this function. Future value is 100. Enter it. PMT is 0. IY is 10% because we are using the effective annual rate of annual compounding. There is 1N. Compute the present value. 90.91. So this will be 90.91. Why it is a negative sign? Because we know that present value has opposite sign compared to the PMT and future value. So now let's discount it with a 6 monthly rate. If you are discounting with a 6 monthly rate, remember 6 months are twice in a year and you have to calculate the half of this rate. So this will be, the N will be 2, IY will be 9.76 over 2, 4.88. Now compute the PV. I have already put 100 in a future value, 0 in a PMT. So compute PV, that will be 90.91. This is 90.91 by the way. Even in previous example, it was when we put the 10% and N1 90.91. So what about if there's a quarterly compounding? There are 4 quarters in a year and IY will be 9.645 divided by 4. Compute the PV, 90.91. It's the same discounting rate. Even in a monthly, 9.57 divided by 12. 12 is the end. Compute the PV, 90.91. So if we discount the $100 back to year 0 by using all of these, answer will be same. Why answer is same? Because all have the same effective annual rate. Why nominal rates are different? Because there are different periodicity of compounding in a year. Why the rate of monthly is lower than the 6 monthly? Because in monthly, nominal rate is lower because there will be 12 times compounding in a year. So 12 times compounding will make this 9.57 equal to 10%. And if there is a twice compounding in a year, 9.76 will be equal to 10% if there is a compounding, if there is a 2 times compounding in a year. And if you want to use the continuous compounding, so how to take the IY? 9.53, divide it with the maximum possible number. So let's say I am dividing it with 1 million. This is IY. So take the N as 1 million. Compute the PV, almost 90.91. So this is the approximation way of calculating the present value if there is a continuous compounding. So that's how you will calculate the present value of future cash flow, and that's been proven that whether you use any rate, present value will be same because all at the same effective annual rate. Now let's learn that how to calculate the present value of future cash flows using these rates. For example, if you want to calculate a discounting of, for example, this is 0, 3 month, 6 month, 9 month, 12 month, and you want to receive 200 at the end of 12 month, and this is a 12% annual rate compounded quarterly. So remember, if there is a single cash flow, and whether it is compounded quarterly, monthly, continuously, annually, you can directly calculate its present value. And how to do that? Clear work? Put the 200 as a future value. If this is compounded quarterly and 12 month is the 4th quarter, 4 is the N, 12% is the annual rate, and compounded quarterly, so it will be 12 divided by 4, it will be 3%. PMT 0, compute the PV, that will be equal to 177.70. 177.70. And if the same question and annual rate is 15% compounded 6 monthly, how to do that? So 15% divided by 2, 7.5 is the IY, there will be 2 6 months in a year. So n will be 2. Compute the PV, that will be 173.07. So if there is a single cash flow and if effective annual rate is given, whether it is compounded quarterly, monthly, annually, you can easily calculate the present value. But you only have to remember, if it is compounded quarterly, calculate the n carefully. Like here, you are receiving cash flow at the end of fourth quarter, at the end of 12 month. So this will be, n will be 4 and this will be 12% divided by 4. Here, if you want to calculate the present value of this 200 after a year with a discounted compounded 6 monthly, so this will be divided by 2 and n will be 2. You have to take care of IY and you have to take care of n. And what about if you're receiving a NVT of cash flows? 3 month, 6 month, 9 month, and 12 month. You're receiving $100 in each of the quarter, and the discount rate is given, for example, 10%, compounded 6 monthly. You cannot use this rate to discount these cash flows. You have to convert it into 3 monthly compounding. So how to convert this? Remember, this will be the nominal rate given. So you will move to second and I conversion, second and clear work. This will be 10% nominal rate and 6 monthly is given. So that means compounding per year will be 2. Calculate the effective annual rate. So effective annual rate is 10.25%. What is effective annual rate? Effective annual rate is that rate which is compounded once in a year. But you need that rate which compounded quarterly in a year. So 3 monthly. So you need to calculate this rate. And how to do that? Keep the effective annual rate same. Compound per year will be 4. Calculate the nominal rate. That will be 9.878%. So using this rate, you can discount these series of cash flows. How to do that? PMT will be 100. Future value 0. N will be 1, 2, 3, 4. This is 9.87 annual percent compounded quarterly. So divide this 9.878 divided with 4. That will be IY. Now compute the PV. This will be 376.47. Let's take the next example. For example, you are receiving $100 at the end of every month. And you want to calculate the present value. Annual rate 20% is given, compounded quarterly. So can we use this rate to discount these monthly cash flows? Obviously no. So first of all, convert this into the monthly compounded. Monthly compounded. So how to do that? Second and I conversion. So nominal rate is 20%. We want to calculate the effective annual rate. Previously, there was a compounding 4 times in a year. So effective annual rate will be 21.55. Do we need to use this rate? No. Effective annual rate means compounding once in a year. So now we need to calculate the monthly compounded rate. That is, keep the effective annual rate same. Keep the compounding is equal to 12 times in a year. Compute the nominal rate. That is 19.67%. So now how to discount these cash flows? PMT is 100. FV is 0, PV we want to calculate, N is 4, and IY will be 19.67 divided by 2. PMT is 100, FV is future value is 0, IY is 19.67 over 12, N will be 4, compute the PV, that will be 384.12. And for example, if you are receiving cash flow after 9 months, for example 200, there is a annual rate of 20% compounded quarterly. So there is no need to convert it or change it. You can directly calculate its present value. How to do it? There is a single cash flow. So 200 is the FV. It is compounded quarterly. So 20%. There will be 4 quarters in a year. And you are receiving payment at the end of 9 months. So it is N is 3. The third quarter. PMT is 0. So compute the present value. That is 172.76. And if this is this 20% and compounded annually, how to calculate the present value? Future value is 200, PMT is 0, compounded annually, so IY is 20, and time is 9, so N will be 9 over 12, that is 0.75, and present value will be 174.44. So if there is a single cash flow, there is no problem of using different rates. You can calculate the present value by using any rate. But if there is an NVT of cash flows, you particularly need that rate which matches with the timing of the NVT. If NVT is after 3 months, you should use the rate which compounds after 3 months. If NVT is after 6 months, you should use the rate which matches, which compounds after 6 months. That's how it will work. Let's solve a question from fixed income, that how to calculate the effective annual yield. What is the annual yield for a bond with the stated YTM of 10%? Remember, whenever YTM is given, whenever any rate is stated, that is nominal rate. So 10% is the nominal rate. When the periodicity of the bond is 2, pay semi-annually, what will be the effective annual yield? So it's very simple. Second and I conversion. Clear this. Nominal rate is 10%. We want to calculate the effective rate. Compound per year is 2, semi-annually. So effective annual rate will be 10.25. And if the periodicity is 4, what is the effective annual rate? Periodicity is 4. Nominal rate is 10%. Effective rate will be 10.38. Second example is an Atlas Corporation bond is quoted with a YTM of 4% on a semi-annual basis. What yields should be used to compare it with a quarterly pay bond and annual pay bond? So this is a nominal yield, because whenever a yield is given, it will be a nominal yield. This is a 6 monthly basis. We want to calculate an equivalent yield in case of quarterly paying bond. So first of all, calculate the effective annual rate. Second and clear work. Nominal rate is 4%. Enter. Previously there was twice compounding in a year. Effective annual rate will be 4.04. So what yield should be used to compare it? So in order to have a comparison, so that means effective annual rate should be the same. So calculate the nominal yield in case of quarterly paying bond. Quarterly, there will be a 4 times compounding in a year. keep the effective annual rate same, compute the nominal rate, that will be 3.98%. And now, if it is an annual paying bond, although we already know the answer that effective annual rate and nominal rate will be same in case of annual compounding, but let's calculate with the help of calculator. Annual compounding means C over Y will be only 1. If effective annual rate is 4.04, nominal rate will also be equal to 4.04. Another example, a 5-year 4.5% semi-annual coupon payment government bond is priced at 98. Calculate the annual yield to maturity stated on a semi-annual basis. This is a number 1 question. Then convert that annual yield to an annual rate that can be used for a direct comparison with otherwise comparable bond that make up quarterly coupon payment and annual coupon payment. Actually, the question is exactly same like the previous one. So first of all, calculate the annual rate in a 6 monthly bond. So PMT is 4.5 over 2, 2.25. PV is 98. FV is 100. N is 10. 5 into 2. So let's calculate. This is 100. 98. 2.25. 10. 2.478 into 2. 4.96 approximate. So IY will be 4.96. This is the nominal yield. So now let's calculate the equivalent yield, the annual rate, which makes us equal with the quarterly bond. So let's move to the I conversion. 4.96 is the nominal rate. Whenever yield you calculate, that will be nominal yield. Enter. We need to calculate the effective annual rate. There were 2 times compounding in a year. Effective annual rate is 5.02. So if there is a 6-month compounding, nominal rate is 4.96. Effective rate is 5.02. So in order to have a direct comparison, you have to keep the effective annual rate same. Calculate the nominal rate if there is a quarterly compound. So quarterly, there are 4 quarters in a year. Keep the effective rate same. Calculate the nominal rate. That is 4.93 approximately. And there is an annual compounding. In order to have the same effective annual rate, there is no need to calculate further. Effective annual rate will be same with the nominal rate. That is 5.02.